So my name's Tim Clark. A little bit about myself before going to the company. I've been with SAS just over 4 years. I'm part of the global IoT practice. So my responsibility is to identify high-growth business partners that work within an ecosystem network and see where the opportunities sit from an analytical point of view to drive growth and drive revenue for the organisation I work for. Prior to that, I worked for IBM in Software Group. I was responsible for B2B engagement, digital supply chain optimization. Prior to that, Microsoft Oracle. But I was then part of Rolls-Royce Aerospace as my engineering background. So I've come from an engineering point of view, but been in solution sales for 16, 17 years. So I work for SAS. People can vary from Special Air Force, so I'm not in the Army. It is an analytical company. People can also think it's a different airline company. Predominantly because we're one of the best kept secrets. We're the largest privately owned software company in the world. Founded in 1974 by Dr. Goodnight. It's based out of North Carolina. It stands for Statistical Analytical System. It was created to look at crop yield and crop yield optimization. But over the years, we've penetrated into 12 distinct markets, so looking from banking to education to insurance, telco, manufacturing. So when you look at your card transaction, your next card transaction, the credit risk is actually underpinned by SAS, Barclays, HSBC. If you look at your tax returns, I'm sorry, but we actually look at fraud, tax fraud and risk associated to HMRC. We look at car tax for DVLA. We look at drug manufacturing, so next time you take an aspirin, we will probably be the production quality analytics that was sat behind GSK, AstraZeneca, Roche. So what this actually means is we're very embedded in a lot of industries, and the reason that we're embedded in a lot of industries is organisations look for quality outcomes. They want to understand what they can get from their data. And this has been going on for centuries. It's not new. Big data is not new to manufacturing. This is my specialist area. And therefore it's about how do you actually extract value. And a lot of the spin or the language that a lot of software companies will use now, it's about outcomes. So we've talked tonight a lot about innovation, technology, networks. What do we do with the Internet of Things? The fundamental question that anyone has to ask is what do you want to actually get from that innovation? Innovation is fantastic. It drives thought progressing design. It comes up with new introductions into market. But from a commercial perspective, it's always very important to focus on why you're trying to do something, because eventually somebody will have to buy it. So what do I see in the market? When I'm talking to customers, I'm talking to partners, the fact is that the Internet of Things is presenting huge, pervasive data. So again, big data is not new to many industries, but pervasive data is. What does pervasive data mean? It can come from anywhere. GPRS tracking, weather systems. It's not just sat within the enterprise anymore. Data that sits with ERP systems have been leveraged for many years. Integrating that with CRM systems, that's been quite relevant and recent. Integrating that with HR systems, integrating the GPRS tracking, weather, this is a bit different because this data has suddenly become much more available and much more easy to get hold of. So coming back to the big question, so what? Organisations are looking for better outcomes. They're looking for quicker time to market. They're looking for better customer engagements. They're looking for deeper insights in their operation to actually drive better processes and stay competitive. And a lot of these businesses are starting to turn towards IoT initiatives to drive this growth and drive this insight. So when we start to look at our approach to things, and it is a skippy little fellow, isn't it? Getting way the end then. So as we build this technology out, we've got pervasive big data only getting bigger, companies looking for better outcomes. From an analytical and SaaS perspective, we're trying to put our innovation into how to get value from the data right at edge. We have a tagline from edge to enterprise. And what that actually means is when you start to apply analytics to any business process, the closer you can get to the business problem to reduce latency, the more value you can deliver to the process or the analytics driving the outcome. So when we look at streaming information, whether it's on a factory line, when we look at information on an oil rig, a satellite, a drug production line, It's all about getting the decision-making process, the application of machine learning or analytics or artificial intelligence closer to the edge or even in stream. So our capability looks at where that information is. We're actually deploying advanced analytics at the edge and in stream. And then we're using the artificial intelligence to feed back into the business process to actually execute a much clearer understanding of what the business is trying to do. So I've just mentioned from edge to enterprise. What does that mean? We partner with companies like NVIDIA for GPU processing. We partner with Intel for CPU processing, Cisco for edge and network devices, partnerships with Siemens, partnerships with companies that really understand their domain expertise. We do not do execution systems, we do not do hardware, we don't do operating systems, we don't do CRM systems. The big key thing that I talk quite often about is work with companies that really understand their domain knowledge, because this is all about an ecosystem. And when you start to engage with businesses that preach a good story about being able to have a full end-to-end capability, I've worked for most of the big companies in the world, and unfortunately they don't. That's a reality. You've got to be able to, and this even goes down to small SMEs, I'm not talking about big corporate businesses. As you go out into the world and try and drive innovation through IoT, look at what the niche capabilities you're trying to do, look at where the value is, and then start to build your strategy from there. So from an edge perspective, it is what I just mentioned, driving better decisions to the edge. Benefits of this, one case could be computer vision. A lot of manufacturers, if they look at the production process line now, they're using GPU-driven, high 4K, 8K, 10K cameras that are looking at the production process as things are spinning past. It is physically impossible for a human to detect some of the faults and errors that are going into high-tech manufacturing of chips, TVs, processing units. We work with Western Digital, Aramco, from an oil production point of view. As all this information is coming through, we're putting intelligence at the edge to make a difference. What does this mean in the reality of an organisation? Collaboration, communication, and getting information to the right people at the right time is always one of the biggest business adoption failures or successes are based around how people use technology and how they can communicate with the outcome of that technology. So collaboration is a key point to drive efficiencies, process, and adoption. When you start to look at all the information that's being passed from pillar to post, there will always be an end point where that data comes at rest. Over recent years, cloud has become much more prevalent. 5 years ago, when I was at IBM, we were talking cloud. People weren't adopting, certainly from an engineering and manufacturing perspective. Now it's almost a de facto. Which cloud are you going with? Where do you want your data? In reality, that data, and we had a great conversation about security earlier, customers are still very nervous about it, and it is about understanding, it's about education, and it will be about how companies prove how secure data is. But it doesn't help when you turn on the TV, every 5 minutes you get a data breach, Apple's being hacked, oh, HSBC's lost your number, Matalan loyalty cards, all gone out on the internet on the dark web. This is a reality of life, because businesses, as they drive innovation, are not actually looking at the full scope of what they're trying to do. And security is definitely one of the key aspects. But when you go beyond the security and the sharing of that data, another aspect is what data do you actually need to put in the cloud? What data do you actually need to save? Do I need an inferencing layer on my data set rather than going into a big data strategy on Hadoop or putting it into an open cloud network? Why do I just filter it and look at what the value I actually want to get from that data? So again, this is where it actually ends the term from edge to enterprise. As you start to put intelligence throughout that strategy, you'll be able to understand what data you have, how secure is it, who's looking at it, how are they sharing it, where is it stored, and how can I access it. So from edge to enterprise actually carries much more deeper meaning of actually how you should be thinking about designing systems, not only from a component perspective, not just a network perspective. What are you trying to achieve and why are you trying to achieve it? My throat's going dry. So I mentioned briefly digital transformation, so I just want to position how I've been placing this and looking for business partners from an IoT perspective about how they can make digital transformation work. And from a SAS point of view, we build all of our innovations around 3 key pillars: data, discovery, deployment. Because where the data is, whether it's structured, unstructured, streaming, from an IoT sensor all the way to at rest, that information needs to be consolidated in for analysis. Discovery, this is all about how do you actually look at the data, how are you mining that data, what are you going to do with that data when you're done with it. And deployment is an absolute critical piece of any analytical strategy. Deployment, if you go around, I always say to many customers, if you say, I want a piece of innovation to be able to do an algorithm for machine learning to look at optimization, kids at university now can write that. Enough time and money, you can write it in any software. You can go back to C++, DOS will write it and deliver that value. The problem, the point around industry is scale, deployment, management, control, and security. A lot of these open source technologies are great for testing in a lab. When you want to productionize, these aren't going to be secure. They're not going to be able to scale. They're not going to actually deliver the big value. So if there's any entrepreneurs in the room thinking about designing the next iPhone, think about what the big picture is. Test, validate, practice, absolutely, with whatever technology you can get. But have a thought process about how you're going to deploy it, how you're going to manufacture it, and the actual value that that end customer is going to get. So back into digital transformation, I start with plan. I talk around how you start to look at demand planning, how you being able to apply the information and collaborate between demand planners, sales operational manufacturers, manufacturing warehouse planning. It's all a key part of the manufacturing process. Sourcing data and procurement information is often overlooked, but most large organisations, which would be 500 million plus, have thousands of suppliers, thousands of ghost suppliers, people that have left their business and still taking a paycheck. These are actually real instances of where people are not actually paying attention to the data. I don't think this works very well. I'll put it down. I've been brave long enough. I'll put it down. So the eight pillar strategy, and I'll accelerate in the concept of time. So make is where you look at production quality. We've all talked about predictive maintenance. If any of you have gone to any of the industry fairs, you'll have seen the notorious spinning engine and looking at a vibrating shaft. Very, very common in a lot of engineering or predictive maintenance fairs. The fact is it goes beyond that. It goes beyond predictive maintenance because you look at condition-based monitoring, failure nodes. How do you tie that back into information that drives value? Once you start linking that to procurement data and delivering logistics data, you suddenly start to become more rich with information and insight in your enterprise. Again, linking that into the consumer. How are you selling your product? Why are you selling the product? Are they going to buy the product again? Information and insight that would feed into your inventory levels. Your inventory levels will be driven by what you can manufacture. You'll only manufacture what you can procure. You'll only procure what you can plan. So all these points really articulate the point of 2 minutes and halfway through. So all these points actually illustrate digital transformation is not just about one area of business, it's about a multitude of areas, and it's about linking these points together. And IoT really does have a key driver in pulling this all together. So I've taken that concept and I've put a few examples around this, and I do apologise, I do like to talk, but I've gone over my time, so I'll just fill this out quickly. You'll get a copy of these slides as well. But looking at where IoT has a key input on these 8 pillars is around putting that insight into action again. Putting intelligence, artificial intelligence, machine learning into stream. Putting sensors on a processor, on a robotic arm, looking at vibration, acoustic sound. Acoustic vibration is absolutely key to a lot of condition-based monitoring strategies and IoT initiatives at the moment. And it's very much at the heart and centre of what companies are doing from a production line perspective. Being able to use route optimization, and I'll fill this out as well. If you go to www.sas.com and type in any of those logos, you will get the full case study. But to pull out a few out of interest, Nestle, they use machine learning for demand planning now. So your Kit Kat has actually got a bit of artificial intelligence embedded around how it got to your plate or in your pocket. If you look at Western Digital, one of the biggest hard drive manufacturers in the world, they use computer vision to be able to look at production quality and how that flies through the process. If you look at Lockheed Martin, manufacturer of most of the biggest aeroplanes globally, they operate with the C-190, and it's a case study that I've actually got in the appendix of this presentation. Using advanced analytics to look at 600 sensors on one plane, every second transmitting information about what should be serviced, when it should be serviced, what's about to fail, what could fail, what won't fail. All this information helping them to maintain uptime on their planes, but also optimise the amount of maintenance they need to do when they're downtime. UPS, this is a great little case study actually. They used a lot of route optimisation to look at counterintuitive routes for fuel optimisation. From a US perspective, not turning left and taking the shortest route saved them 135 million a week, just by going a counterintuitive route, because sat at an intersection and not turning was burning fuel. And when you look at the scale of different capabilities out there, the numbers start to add up. HSBC, visualization, Levi's, supply chain distribution, shop directs, very.co.uk, one of the biggest pure retailers in the UK, all driven by SAS, next best decision. So if anyone goes up and types in black jeans in very.uk, it's SAS that's telling you, buy these red ones. So you get a copy of these, I'm not lying. So I'll distribute these. I was going to go into a bit more detail about some of the case studies of the application of artificial intelligence, the application of machine learning. But again, this was a great case study that we've got online. I know Mike Isbell personally, spoke to him at length about how he was able to build up a data-driven insight and analytics team and the power and influence that took. It was a huge transformation for a business to go from a very engineering world of, if it smells of oil and I can touch it, I'll invest, to someone talking about data, the investment data. Are you willing to invest in this strategy that has outcomes, and I will prove an algorithm will predict more accurately than a human? Huge time for adoption. So again, when you look at projects and you're trying to, if there are entrepreneurs in the room looking at trying to position technologies into bigger companies, think about adoption, the route to that adoption, and how usability. And again, because of the topic of the day, I will also say security. As you build these into your innovations and your technologies, you'll be able to get quicker route to market and be able to articulate your message to your customers. This was a metal machine manufacturing, and this was Volvo trucks. All three very good case studies. I can go into more detail if I get permission from Mum.
Yeah, I thought if everybody else would like to hear a bit more information.
Well, is there another talk? Oh no, that's great. Oh, that's great. That's fine.
Everyone interested?
Yes.
Outstanding. Okay. So Lockheed Martin. I mean, the best way to explain this. Are there any questions? Do you know who Lockheed Martin is?
Yeah,
aircraft manufacturer. So the C-130J, that's the big one that can land on anything. Ice, water. They put pontoons on it. They land it all over the desert. It's got the big 4 propellers. Huge operational aircraft. I think it's been in operation for, I think it's about 40 years, 50 years. So it's got an outstanding service history. But the way that Mike Isbell went around building his data science team, again, was looking at what are the key drivers. Why am I actually looking at innovation through this? So as he started to put more and more sensors on, the question became, what am I going to do with this data? So as the data started coming in, there was big, if you work in the aviation industry, there are a lot of considerations about what you can transmit while you're in flight, or what you transmit when you land. Being able to capture launch data, cruise data. There are some critical data, there's some non-so-critical. False negatives, false positives. These are big issues in the aerospace industry about not panicking. Working at Rolls-Royce, I've got a very clear insight in how they use total care, which is the servitization of their jet engines. They stopped selling jet engines about 15, 20 years ago and started selling power by the hour. So power by the hour to Airbus and Boeing was a fantastic commercial option. Frees up working capital, allows them to buy just power units. The challenge that Rolls-Royce had to have is, well, when that breaks, that costs me money. How am I going to know when it breaks? If it does break, how long is it going to be down for? It costs me $1 million a day on a fleet. So these big business driving questions were all driven through data innovations. And the way that, again, Mike and his team did a sterling job in implementing into Lockheed Martin, because it's been established for about 4 years, is just articulating that message to the seniors that this value-driven insight and this data-driven insight can actually add value into keeping this operational business up and running. From a C-130J perspective, it was about critical business as its MOD. From a Rolls-Royce perspective, it was about commercial influence. The metal sheet manufacturing was all driven around how you get OEE up. So I don't know how many engineers are in the room, but overall equipment effectiveness. It's a big KPI in the manufacturing industry. And as you've got sheet metalling being produced, again, how to detect quality quickly, how to fail quickly, are big operational engineering manufacturing questions. The application of analytics for IoT was the deployment of sensors, being able to deploy them not just on a machine, but understand exactly where on that machine to place them. When you don't get the rich data that you need and you're not getting the outcomes, fail quickly, evolve, be able to put a process in place that can deliver the value of what you're actually trying to achieve. And finally, the Volvo trucks and Mack trucks. So this was a recent one. It was a big data challenge because they had 175,000 trucks in North America. So as you start to go into smart mobility and look at what organisations are doing in the automotive sector, we've all seen Tesla, the self-driving car, Google car, running people over in California. These are all just the iterative processes. They get closer and closer. But I don't know if any of you have had the joy of driving in a Tesla. The automotive ability is quite scary, but it's coming. And it's moving at such a pace, and the automotive sector is driving it. We will end up in a position where this will be something quite standard in most automotive vehicles. But it's how you get the data and the info and the insight to make that safe and to make that truly valuable for a customer who wants to buy it. Again, I'll use the term servitization because this is coming to the automotive industry. In the next 10 to 20 years, we won't actually buy a car. What we'll be doing, we'll be subscribing to a brand. You will subscribe to a brand, you will have a fixed amount per month, and you will pay that brand that amount of money. And they will profile through your personal data and through their manufacturing data and location data what you actually want. Do you want the 4x4 this weekend? Because I can see from your calendar you're going away with the kids. Monday you've got a meeting in London, I'd take the train. All information like this will suddenly start to be integrated. So again, this relates back to how IoT is having a profound effect on the way that we live. Connected watches, smart trainers, all this information coming across. How businesses deal with that is going to be the fundamental change point of how they stay competitive. In this particular example, Volvo is taking the key step of putting an analytic AA strategy together to score out all the data that's coming from these 175,000 trucks, knowing when a turbo is going to fail, being able to put the right parts distributed the other side on the west coast when all the parts are on the east coast. How do I do that efficiently? Expediting spares in the automotive business can cost multi-billions of dollars a year, purely down to the fact that nobody'd scheduled it properly. So being able to tackle these business challenges, when you think about IoT, it is much bigger than taking a little bit of data from a sensor and putting it into a database. The profound impact that it's having on industry is growing, and it's only getting bigger. I hope you enjoyed that.